All right, so now we're looking at problem number 10. It wants us to give the domains where each of these functions is continuous. So we just need to take a look. What are the two main places where a function's not going to be continuous? Your big issues are going to be when you have a negative under a square root or when you're dividing by 0. So let's see. For 10, we have particularly 10a. That's just a polynomial. So that function is continuous everywhere. You shouldn't write continuous everywhere. I would write minus infinity to infinity in interval notation. This is how we say things in a more kind of mature mathematical way. Next is sine of x times cosine of x. So sine of x is continuous, cosine of x is continuous. So therefore, it's going to be the same thing. Minus infinity to infinity is where that's going to be continuous. C, I have x minus 3 over x squared plus 9. So we might be concerned about that x squared plus 9, but if you think for just a second, you can remember x squared is always bigger than 0. 9 is bigger than 0. So that denominator is always going to be a positive number. And I put that one in there because you might accidentally get tricked into thinking that that's difference of squares, but that only happens if it's x squared minus 9, not x squared plus 9. So that bottom is greater than 0 everywhere. The top and bottom are continuous, so that function is continuous everywhere. Finally, D, we have square root 1 over square root x minus 3. So the function doesn't even exist, does not exist if x is less than 3. Actually less than or equal to, right? Because if I'm less than 3, I get a negative in the square root, and I have 1 over square root of a negative number which doesn't exist. If x is 3, I have 1 over square root 3 minus 3 is 1 over square root of 0 is 1 over 0, which also doesn't exist. So this function is continuous from 3 to infinity. And that's where it's continuous. And that does number 10.